Namaste. Today we begin a new module which is Resources and Conservation. This module will have three lectures: Land Resources and Agriculture, Water Resources, and Mineral and Energy Resources. So let us begin with Land Resources and Agriculture. Now when we talk about resources, the first question that comes to mind is what is a resource? When do we call something as a resource? So a resource is defined as a source of supply, support or aid that can be readily drawn upon when needed. So a resource is a source of supply of something, support or aid. And the good thing about the resource is that it can be readily drawn upon when needed. So you can use this particular source when you need it. Examples include natural resources and human resources. So a natural resource is a resource that exists without the actions of humans. So we do not need to do anything and they exist, because of which they are a natural resource. Things include rainforests. Now resources can be differentiated or classified in several ways. On the basis of their origin, we can have biotech resources. Now biotech resources are those that come from living matter or from biological things, such as timber. So if you have a forest and this forest has lots of trees, then this is a resource because you can make use of the timber. So this forest is a source of a supply of timber that can be readily drawn upon when you need it. So if you need timber, you can always go to the forest and harvest the timber, because of which your forest is a natural resource. Now this is a natural resource, but among the natural resources, this is a biotech resource because this timber is coming from biological organisms, in this particular case trees. Now together with biotech resources, we also have abiotic resources, those that come from non-living matter such as iron ore. Another classification is on the basis of renewability. So we have renewable resources and non-renewable resources. Renewable resources are those resources that can be replenished naturally, such as sunlight. So when we talk about sunlight, we have sunlight every day. So nature is replenishing the supply of sunlight, because of which it is a renewable resource. It is a replenishable resource. Another resource is a non-renewable resource. Those resources that either form slowly or do not naturally form at all in the environment. Example, things like coal. Now coal takes millions of years to form. So it is formed so slowly that if you use up all the coal sources or all the coal reserves that you have, then it will again take millions of years to produce the next supply of coal. And because of this, we call it a non-renewable resource. The nature is not able to renew it soon enough. So on the one hand, when we talk about the renewable resources, we will never run out of them because the nature is replenishing them. Whereas when we talk about non-renewable resources, then we may very easily run out of them. And once we have used up our stocks, then we may have a situation where there is no more of the non-renewable resource that is left. And even more so because nature either does not produce it now, or when nature produces it, it produces it at such a slow pace that it does not matter. Then on the basis of the stage of development, we can have resources classified into four categories. So we can have potential resources, those resources that may be used in the future. Example, oil that has not been drilled. So we are not currently using that oil, but we can use it in future, because of which it is a potential resource. Then we have actual resources, those resources that are currently being used after surveying, quantification and qualification, such as timber from forest. So if there is a forest and we are taking timber out of it, then it becomes an actual resource because it is currently being used. And typically we make use of a resource after surveying, quantification and qualification, because we need to know how much of the resource do we have, where do we have it, and of what quality do we have it. So when we talk about actual resources, those are the resources that are actually currently being used. Then we have reserve resources. It is the part of the actual resources that can be developed profitably in the future. Example, low concentration ores. So when we do a mining operation, we can have high concentration ores and we can have low concentration ores. Now, high concentration ores have a higher concentration of the requisite mineral that you want, typically metals. Now, because the concentration is high enough, it is profitable to extract those ores and use them. On the other hand, there are also a large number of ores where the concentration is not high enough today. So today it is not profitable to use those. But with advancements of technology, probably we will be able to increase our efficiency, bring down costs, and in that time it will become profitable once again. So those are the reserve resources. They are part of the actual resources. So they are actually currently being used, but we do not use them because they are currently non-profitable, but they can be developed profitably in the future. So currently we do not use them, we just leave them as such to come back in a later stage. Now, when we talk about a large number of mines, especially those for the precious metals, so when we talk about things like gold mines or silver mines, then currently people are going into those areas where the mines used to operate sometime in the past, because in the past our technologies were even more primitive, and so people could make use of only very high concentration ores, and so they left those ores that had high concentration and low concentration. Now our technologies are much more developed, so we can make use of the high concentration ores. The highest concentration ores have already been used, but the high concentration ores, we are still using them, but we are leaving out the low concentration ores. Probably sometime in the future it will become profitable to extract the metals from the low concentration ores as well. So these are the reserve resources. Then we have stock resources. Those resources that have been surveyed but we lack the technology to use them. Example, hydrogen for nuclear fusion. So similar to the nuclear fusion that occurs in the stars, we can also perform nuclear fusion on the land. A very good example is the hydrogen bomb. So when we use hydrogen bomb, we are actually using the fusion process to join hydrogen nuclei together and to produce helium. And in this process, a tremendous amount of energy is released. But currently it is only being used for destructive purposes because we lack the technology to make the energy release in a slow manner in which we can actually use it for, say, the generation of electricity. Now, we know how much amount of hydrogen do we have on this planet, because most of the hydrogen is in the form of water, and we know how much amount of water we have. But if we wanted to use this hydrogen for nuclear fusion purposes, we currently lack the technology. And so we will say that these are stock resources. They have been surveyed, but we lack the technology to use them. So on the basis of the stages of development, natural resources can be potential, actual, reserve or stock resources. Now, one of the most important natural resources is land. So land is all of the lithosphere. And when we talk about land, currently the land is divided or is covered by different kinds of vegetations. So we can have evergreen needle-leaf forest, evergreen broadleaf forest, deciduous forest, mixed forest and so on. Now this is the natural distribution of vegetation on the planet. But what we humans do is that we can convert these portions for our own use. So for example, most of Brazil is an evergreen forest, but we can cut these forests, free up the land and probably use that land for agriculture or for raising cattle. So the land is a natural resource, but land use has been changing. And these land use changes have large conservation implications. So if we look at the land use over the long term, so from 100 AD to the 21st century, we will find that the proportion of land that is being used for croplands, it has been slowly rising. Earlier the rise was very little, but now with the advent of technology, now we can increase it at a very fast pace. If we look at the amount of land that is under grazing, that has also been increasing. And if we look at the amount of land that is under built up area, so in these regions it is very difficult to see the yellow line, but here we can very clearly discern that there is a substantial amount of built up area. Now the amounts of lands or the portions of land for agriculture or for grazing or for the built up areas, they have been increasing primarily because of two things. One, our population is increasing. So we now need more food, we now need more milk, we need more houses. But even as important as this is the fact that now we have the technology to make these changes. Earlier, even if somebody wanted to make a change in the land use pattern of the world, they did not have sufficient resources to do that. After all, how many trees can a person cut in a single day? But today, with the advent of machines, we can make large scale destructions. Now this technology is permitting us to make land use changes in a very fast manner, and that is giving us conservation implications. And two of the major land uses today are cropland and grazing. So essentially agriculture dominates the current land use. So if you look at the earth's surface, 29% is land and the rest is water. Now out of this 29%, we have 10% which is glaciers. 19% of this 29% is barren land and 71% is habitable land. That is, if we remove the glaciers and the barren lands, this is the area that is available. So this is 104 million square kilometers. And of this 71%, as much as 50% is being used by agriculture. And 37% is being used by forests, and rest we have the shrubs and other areas. So of all the habitable land, 50% is being used for agriculture. So agriculture dominates the current land use. And out of this 50%, 77% of this 50% is being used for livestock and dairy. That is for cattle and for grazing. And only 23% is for crops. So crops still comprise the minor portion of the agricultural land. But the good thing about crops is that they provide the majority share of the global calories. That is, they are the predominant sources of food. As much as 82% of the calories are being taken from the plant-based foods. And they are supplying 63% of all the global protein supply. So the essential things to note here is that the major portion of the lithosphere is habitable land, out of which as much as 50% is being used for agriculture, and in agriculture the dairy and animal rearing dominates, but it provides very less amount of food and it provides a less amount of proteins. Now if we look at both of these, we will find that the cropland use has been increasing over the years. So in this chart we have the years, so from 1600 AD to 2016 AD, and on the y-axis we have the area that is under cropland use. And we can find that the curve is increasing over the years. And there is an increase everywhere. There is an increase in Oceania, increase in Africa, India, China, all the areas we are finding an increase. Similarly, if we plotted grazing area also is increasing everywhere. And much of this increase is coming from converting forests. So where do we get the land to cultivate and to rear cattle? In a majority of cases, we are taking this land from the forests. So we do a clear cutting of the forest and convert that land into our crop fields or grazing areas. And in a large number of countries, the majority of the land area is now agriculture. In some countries, as much as greater than 90%. So in this chart, we can see that in a large number of countries, a very great amount of land is under agriculture. And we can look at what kinds of changes it brings about by looking at this example of rainforest deforestation. So this is from the Amazons. So this is an area in Brazil that is known as Rondônia. And this is the satellite imagery of Rondônia in 1975. Now, if you concentrate on this road, this is something that is going to be common in the next few images. So this is Rondônia in 1975. This is Rondônia in 1984. So in one of the earlier lectures, we had talked about the impacts of linear infrastructure such as roads. Once you make a road, once you have dissected a natural habitat, you permit people access into the forest areas. Now this access typically brings about a large amount of destruction in the forest. So in this picture, what we can observe is that once this road was built, people had access inside and now they started to cut trees. So there is this strip on which the major chunk of forest cutting is happening, and then people are cutting on both the sides of this small track. Similarly here. So in 1975 it was all green. By 1984 we are now observing large scale deforestation. This is 1985, 86, 87, 95. Now you can observe this road is the same, but now more and more amount of area is being taken out from the forest. It is being deforested. 96, 98, and now you can observe that in a large number of these areas, we are now also observing agriculture, both croplands and cattle rearing. So these square shaped plots are very commonly observed when a land is shifted into agricultural purposes. So 2002, now you see that these croplands are now also increasing. Now you will again make a correlation with the habitat fragmentation that we were talking about. So once you have people that have entered into the forest area, now they will require certain lands to meet their own needs. So the people who have entered inside, they also need food supply. So they will start with a small field, or they will say keep a few cattle, and slowly and steadily this portion will increase to the detriment of the natural forest. So this is Rondônia in 2002, this is 2007, this is 2013, 2015, 2016. So now hardly any portion of the forest is left. So you'll remember that we had talked about things like attrition. So the small patches that are left of the natural forest, they are now getting more and more smaller, because people are eating away into these forests. They are using up these forests not just for timber, but also they need the land for cultivation and for cattle rearing. So this is Rondônia in 2016. So this is Rondônia in 1975, and this is Rondônia in 2016. And here again, if you track this road is the same in 1975 and in 2016. We still have this road, which led to this large scale destruction of the forest. Now once this forest has been destroyed, there will be large scale ecological imbalances, which we are already observing in large portions of the world. Once these areas have been cleared, the soil moves away, the biodiversity gets lost, we are finding more and more amounts of floods, more and more amount of sediments that are getting deposited in different areas, and so on. At the same time, when this deforestation had not occurred, these forests were a storehouse of carbon. They were doing carbon sequestration during the process of photosynthesis and taking carbon dioxide from the atmosphere and storing it in their bodies in the form of biomass. But once this area is cleared, then all of this carbon has been lost. Now, not only because the wood, once it has been removed, it decays or it is burnt, but also because when you have a well functioning ecosystem, quite a lot of carbon is also stored in the soil in the form of decaying matter in different stages. So once the tree cover is lost, all of that carbon in the soil is also released back into the atmosphere. And today when we talk about global warming, when we talk about climate changes, a very big portion of the carbon is also coming from these deforestation activities. So agriculture has huge impacts on land use and also on the functioning of different ecosystems. Now, when we talk about the diversion of land for agricultural purposes, what are we actually cultivating and where? Now, if you look at the global agricultural land use by major crop types, and here we are having the areas in hectares. So around 700 million hectares of land is under cereal cultivation. Cereals include things like rice and wheat. Around 325 million hectares is under coarse grains. Coarse grains like jowar, bajra or ragi. The land under the oil crops has been increasing very fast. So from around 100 million hectares in 1961 to around 300 million hectares today. So the share of oil crops has been increasing primarily because of large scale deforestations that have been done to grow oil palm. So with industrialization, now more and more of our food is processed food. And to make that processed food, if you look at the labels of any of the processed food, you will find that it will have palm oil or palmolene oil. Now this palm oil has been grown in a large number of equatorial rainforests by clearing them. So large portions of the forests are clear filled, and then the area is mostly burnt to completely clear the area, and then the oil palms are grown there. So the share of oil crops has been increasing very fast because now more and more of the world is shifting towards processed foods. And then a small portion is under pulses, roots and tubers, vegetables, fruits, tree nuts, citrus fruits and jute. So these are the major crops. And different areas have different productions. So if you look at cereal production, we'll find that China is one of the biggest cereal producers. Then we have the US, India and Russia. Whereas other areas do have cereal production but in smaller quantities. If you look at wheat production, China is one of the largest producers of wheat, and appreciable production also happens in US, Russia and India. Maize production, again we have China, US and Brazil. So in these charts, what we are observing is that the impact of different crops is different in different areas, because culturally or because of the climate, different areas are growing different crops. Now, if you look at rice production, the majority of rice production is in China, India and Southeast Asia. Barley production, you'll have Russia and some countries in Europe like France. Rye production, again you have Russia and a few countries in Europe. Cassava production, now cassava is a root crop. So this is mostly grown in areas in Africa and in Brazil and some parts of Southeast Asia. Yams, mostly in Africa South America, Japan. Potato, you have China as one of the largest producers, followed by India, US, Russia, and a few European countries. Soybeans, here we have US and Brazil. So when we talk about the deforestation in Brazil, a major chunk is being used for soybean production. So there are two things because of which there is a large scale deforestation in Brazil. One is for the production of soybeans and two is for cattle rearing. Then if you look at bean production, you have large number of countries, primarily China, India, US, Mexico and Brazil. Pea production, again you have China. So you'll find that China is a very large producer of most of the food crops. So in peas you have China, Russia and the US. Bananas, again you have China and India, plus Brazil is also a big producer. Oranges, again you have China, India and Brazil. Apple, again you have China, plus a small share in the US and in Asia. Grapes, again you have China, you have the US and a few European countries. Then in sugarcane, we have number one is Brazil, followed by India and China. Sugar beet is mostly grown in colder areas, so areas like Russia or France or the US. Palm oil production is mostly in the equatorial areas. So here again, palm oil is another crop because of which we are seeing large scale deforestation, typically in the Southeast Asian nations such as Indonesia. So a large portions of these lands are being clear filled, burnt and used for palm oil production. Nations in Central and South America and in Africa and also China are also important producers of palm oil. Then rapeseed or mustard production, here again we have China, India, Canada, and these are followed by Russia, the US, Australia and some countries in Europe. Sunflower seed production, again you have China, you have Russia and we have Argentina. Next, in sesame seed production, we have India, Myanmar and a few countries in Africa that are the largest producers. Cocoa bean production is very prominent in Brazil, certain countries in Africa and in Southeast Asia. Coffee again is more of an equatorial crop, so we have large production in South America, Africa, India, China and Southeast Asia. Tea production, India and China are the largest producers. Tobacco production, the largest producer is China, followed by Brazil and India. Then if you look at animal production, then meat production, again China is the leader, followed by US and Brazil and Russia. And if you look at the trends in animal production, if you look at the global meat production, it has been increasing. So from 1961 to today, it has been increasing. And the increases there everywhere. In Asia, there has been a very rapid increase, but we also have increase in Europe, North America, South America and other areas. Now, of these animals, the majority is poultry, and poultry has also shown a very fast increase, primarily because people prefer to eat poultry and it is easy to rear. Next, we also have a large section that is eating pig meat, followed by beef and buffalo, sheep and goat, guinea fowl and other species. Now, if you look at the meat supply per person, then it is maximum in the case of US, in the case of Australia, followed by certain countries in Europe and South America. Now, the important point to note here is that when a country becomes more and more rich, when a society has more amount of money with it, typically we observe that the amount of consumption of meat increases. So meat is typically a more expensive food, and when people have more amount of money, they shift their preferences to this expensive food. So we had already observed that when we talk about the land use, then the major chunk of land under agriculture is being used for the animal rearing and not for the cultivation of crops. But if you look at the amount of calories or the amount of proteins that meat provides or these animals provide, it is a minor share as compared to the crops. Now, this explains why it is more expensive, because for a smaller amount of calorie, for a smaller amount of proteins, you have to devote a very large chunk of area for its production. Now, if we drew a plot between the GDP per capita, so on the x-axis we have GDP per capita, which is representing the amount of affluence in a society, and on the y-axis we have the meat supply per person, and we can observe that there is an increasing trend. So when people have more money, they consume more meat. Now this is becoming important because as more and more people are shifted out of poverty and the affluence levels in different portions of the world are increasing, now people are demanding more and more meat. Now in that case, we will require an even larger share of land to be used for rearing these animals for a very small portion of calorie and protein intake, and that would increase our impacts on the ecosystems. Typically because large chunks of forest will have to be clear filled and converted into pasture lands. Now, if you look at milk production, India is one of the largest producers of milk, followed by the US and Russia. But if you look at per capita milk consumption, then India does not fare that well. The per capita milk consumption, including the milk products, is very high in the case of US, Australia and certain European countries. Because in our country the population is so large that the per capita milk consumption becomes smaller, even though we are the largest producer of milk in the world. In the case of egg production, the largest share is China, India and US. But again, if you look at per capita egg consumption, India does not fare that well. If you look at the number of cattle, the highest number of cattle are in Brazil and in India. Now, in India, most of the cattle are being used for milk production. In Brazil, most of them are being used for the production of meat. If you look at the number of poultry birds, it is highest in the case of China, in the case of the US, Brazil and certain other regions of the world. If you look at the number of pigs, it is highest in China, followed by the US and Brazil. Then if you look at the marine and aquatic animals, then the seafood and fish production again has been increasing. So if you look at freshwater fish, they have been increasing, pelagic fish increasing, demersal fish increasing, marine fish increasing and so on. So now the world is using a very great amount of seafood. So our consumption has been increasing. Now if you look at the fish and seafood consumption per capita, we will find that a large number of countries, especially those that are near the sea coast, they are having a very large amount of fish consumption. So primarily we have countries like Spain, France, Finland and Sweden, and here we have Myanmar, Southeast Asia, Japan, we have China. So you have a very large amount of seafood consumption per capita in these countries. If you look at capture fishery, now capture fishery refers to the fishes that are captured from the wild conditions, typically the ones that are being captured from our oceans. Now that is capture fishery. So in the case of capture fishery, large sized boats and ships venture into the oceans, use large sized trawlers and nets, catch a large number of fishes and bring them to the shore. Now if you look at capture fishery, then China holds the majority, followed by India, certain countries in Southeast Asia, the US, Russia and certain countries in Africa and South America. Now if you look at the global wild fishery catch by sector, we'll find that the industrial or the large scale commercial fishery, it has increased like anything. So in the 1950s, we were capturing like 15 million tons of fishes, but then it increased to as high as, say, around 100 million tons. So from 15 to 100 in a span of just 40-45 years. But then we overused our resources, and so the industrial fishery is now towards a decline. Fishery, it is now on the decline because we have overutilized our resources. The small scale commercial fishery is still on the increase, and in a large number of cases this fishery is happening in the large size lakes. Then if you look at the number of discards, they increased till the 1990s. So there was this one hump, then another hump, and now it is on the decline. And a small amount of sustenance and recreational fishing is also happening. Now if we look at the share of global fish stocks that are not overexploited, we see that there is a decreasing trend. That is, roughly around 65% of our stocks are not overexploited, and around 35% of our stocks are already overexploited, which is a very serious cause of concern. Now, if we look at the capture fisheries versus aquaculture, we will observe that the capture fisheries, they have already reached the peak. So now this cannot increase any further. And so now more and more attention is being shifted towards aquaculture. Now, aquaculture is the farming of aquatic organisms, including fish, mollusks, crustacean, and aquatic plants. Now, if this aquaculture has to increase, where would the land come from? Now, it turns out that we are now using more and more of our natural ecosystems, the natural ponds and lakes, into aquacultural uses. In certain cases, people are also digging large sized trenches on the land, putting up a sheet of plastic and filling it up with water to be used for aquaculture purposes. Now, again, here we can observe that now we require more and more amount of land to meet our requirements of fish. Now, where would this land come from? Again, it is coming from the natural habitats. So everywhere you can observe that we are using more and more of our natural ecosystems and converting them into our own purposes. If you look at aquaculture production, we find that China and countries in the Southeast Asia are now the largest producers of aquaculture products. Now, all of this is not without impacts. We are observing large amounts of impacts on the ecosystem. If you look at the greenhouse gases, then 26% of the global greenhouse gas emissions is coming from the food sector. If you look at land use, we have already observed that 50% of the global habitable land is now under agriculture. If you look at freshwater use, 70% of the global freshwater withdrawals are happening for agriculture. 78% of global ocean and freshwater pollution, including eutrophication, is because of agriculture. Because we are using large quantities of fertilizers and manures in our croplands, and when it rains, then these fertilizers and manures make their way into the water bodies. Once they reach there, the algae bloom like anything, the aquatic plants bloom like anything. They take up all the space in the water body, and when they die and decay, then all the oxygen is used up and the lake becomes a dead lake. That is eutrophication. And as much as 78% of this eutrophication can be ascribed to the agricultural sector. If you look at biodiversity, then of all the mammals in the world, excluding humans, 94% of the mammalian biomass is now livestock. That is animals like cow, buffalo, goat, sheep. And only 6% of the whole biomass of mammals is vested with the wild mammals. So we are taking away all of their habitats and we are using them for our own purposes. So the livestock populations are increasing and the mammalian populations are decreasing. So these are some sorts of impacts that we are having. Large portion of greenhouse gas emissions, land use, freshwater use, eutrophication and other pollution, and biodiversity loss. All of that because of agriculture. Now, if we look at the greenhouse gas emissions, so we saw that 26% is coming from the food sector. And if you look at where is this 26% coming from? So, if we convert that into 100%, we find that 24% is coming because of changes in the land use. Crop production is giving 27%. Livestock and fisheries are giving out 31%, and supply chain is giving out 18%. So when we talk about food production, there is greenhouse gas emission everywhere. When we convert land to be used for agricultural purposes, when we grow crops, when we rear animals, and when we transport things, when we process things to make processed foods, everywhere there is a greenhouse gas emission that is occurring. And greenhouse emission leads to global warming and climate change. And in this case, there are certain food products that are playing a very large role. So if we look at things like beef or lamb and mutton and cheese, we find that the amount of greenhouse gas emissions is very large. Now, if we look at the amount of greenhouse gas emissions, then if we consider beef, then we are producing 25 kgs of carbon dioxide equivalent for producing 100 grams of protein in the form of beef. So it is a highly greenhouse gas intensive source of protein. If you look at lamb, it is 20 kgs. If you look at farmed shrimp, it is 10 kgs. Now 10 kgs of carbon dioxide released for just 100 grams of protein in the form of shrimp. In the case of cheese, it is around 8.4 kg. For pork, it is 6.5 kg. Chicken is 4.3. Eggs is 3.8. Farmed fish, 3.5 kg. Tofu, which is coming from soybean, is 1.6 kg. Now, above this line, we are seeing all of these are the non-vegetarian products, animal source proteins. Now, animal source proteins give out the majority of share of greenhouse gas emissions when we talk about the gases emitted per 100 grams of protein. But if you look at the vegetarian sources, then tofu is 1.6 kg, beans is 0.65 kg, peas is 0.36 kg, so 360 grams of carbon dioxide released to make 100 grams of protein. And in the case of many nuts, it is negative. So it is minus 0.8 kg. 800 grams of carbon dioxide are absorbed, sequestered and stored, taken away from the atmosphere for every 100 grams of protein. So the different food products have different impacts. That is the important thing here. This means that if we wish to reduce our impacts on the ecosystems, one easy way out is to change our dietary preferences. By shifting away from animal source foods and by shifting towards plant-based foods, we can reduce the impacts on the environment. Because by doing that, we will contribute in releasing less amount of carbon dioxide into the atmosphere, and we will contribute towards less amount of diversion of forests for the cultivation of food. Because if we shift to the plant sources, then we get the same amount of calories and proteins from a smaller portion of land. And so if we shift to plant sources of energy, plant sources of food, then because the efficiency of food production increases, so our impacts will be lessened, because we will be requiring a smaller portion of land to produce sufficient amount of food for everybody. So that is a more sustainable way of getting our food. Now, remember that when we talk about sustainability, we need to meet everybody's present needs, but not the wants of everybody. Now, needs can be fulfilled by the plant sources of food very easily. Another major change that we can do is by reducing the waste. As much as 6% of global greenhouse gas emissions are coming from food losses and waste. That is, if the food production is responsible for 26%, out of this 26%, a sum of 6% is because of the food wastage. Food is lost in the supply chain, and also people waste food when they are eating. When we are talking about the food loss in the supply chains, we are talking about the food that gets crushed or that gets rotten during the supply process. And when we talk about the consumer level food wastage, we are talking about people who are buying more amount of food, but they are unable to consume it within time, and so they throw it out. Once that happens, we are not just talking about food and money, we are also talking about the impacts to the environment, the release of greenhouse gases that has happened during the production and transport of this food. That is also a wasteful impact that we are making to the environment. So this is again something that can very easily be sorted out. So easy ways are to shift to plant-based food sources and to reduce the amount of wastage that we do at own personal levels and also at the level of the supply chain. And this is very essential because of the numerous impacts that agriculture is causing to the ecosystems. We have looked at deforestation, but it is also increasing soil erosion, increasing sedimentation in the waterways, climate change, especially because of global warming, and an increase in soil salinity and soil alkalinity because of two reasons. One is the overdoing of irrigation. So when we put water to the soil to the plants, then this water typically brings with it certain salts that are released during the weathering process of rocks. Now when this water has been put to the plants, the water slowly gets evaporated, water is also absorbed and it is transpired, but the salts are left in the soil. So this increases the salinity of the soil. At the same time, in the case of a large number of fertilizers, you can have certain ions that are left in the soil. So for example, if you add say sodium nitrate into the soil, then the plants, if they use up the nitrate portion, the sodium portion would remain, increasing the alkalinity of the soil. Now increased salinity and alkalinity make the soil infertile, and at the same time they also lead to the death of soil biota, because a large number of organisms cannot live under such conditions. At the same time, the overuse of pesticides is leading to the death of pollinators and biodiversity. We are also getting cases of waterlogging, water contamination, eutrophication, and disruption of food chains. Disruption of water flow because of reduced flow into the rivers, or disruption of lentic habitats, or disruption of wetlands, reduced discharge to the sea, increasing depth of water table with consequences for numerous plants, stagnation and proliferation of disease vectors. Now these are all different impacts of agriculture on the ecosystems. There is subsidence of land that is happening, especially in those areas where the land is being built upon, or the land is being irrigated from above and the water table is being depleted from below. So in those cases, the land would just subside, it would come down. Then we also have impacts of the genetically modified crops that are now being used. And there is a large scale pollution that is happening because of agriculture. Now, these are not just theoretical aspects, we are observing them in our daily lives. These are impacting the human development of our societies, because of which we have to be very careful. And a good example is brought from the Delhi smog in our country. Now, we know that in the winter months, Delhi is full of smog. So smog refers to smoke plus fog. So this is a foggy condition that has been created near the ground and it is full of smoke. Now the question is, what is causing this? So every year we get these news items that Delhi blanketed in toxic haze has become a gas chamber, or that millions of masks are being distributed because Delhi has become a gas chamber. Now the question is, why does Delhi become this gas chamber? and we can have certain insights from the geographical point of view. If you look at the temperatures in Delhi during these periods, so here we have plotted from 1st of October to 14th of November. In this period, if you look at the maximum and the minimum temperature, both are towards a decline, because these are the cold months, these are the cold weather seasons, and so the temperatures are going down. Now, if you look at the precipitation, then we'll find that in Delhi there is hardly any precipitation in these months. If you look at the relative humidity, then we'll find that in the mornings the relative humidity is very close to 100%, because the air temperatures are going down. Now, when you have a high relative humidity, it creates a very good condition for the creation of fog, because the water in the air in the form of water vapor, it condenses on the smoke and dust particles and it creates a fog. Now, if you look at the wind speed, the wind speeds are also towards a decline. Now, this is important because if you have high wind speeds, then any pollutant that is there in the atmosphere, it will be diluted out. It will be spread to large areas. Now, in this case, the wind speeds are pretty low. Now, in these conditions, we have a condition of temperature inversion. Now, what happens is that in a normal day, the earth is warm because it is being heated by the sun, whereas the upper layers of the atmosphere in the troposphere, they are colder. Now, because hot air rises, so it takes all the pollutants away. So, in the summer months, you won't find a smog or a very toxic condition in Delhi. But in the winter months, what is happening is that you have a ground that is cold, and the air above is a bit warmer than this cold air. Now, in these conditions, because the cold air is denser, so it stays down and it is covered by this lid of the hot air. Now, this cold air does not rise, and so any pollutants that are released into this air, these will remain trapped in this air. So, once you have this condition of temperature inversion, if you release any pollutants into this air, those pollutants will stay put. So, after a while, it does not matter where the smoke is coming from. You release any smoke and the smoke will be kept there, because the conditions are such that winds or convection currents are not able to take them away. And it is during these periods that we observe an increase in the PM10 concentration, PM2.5 concentration, nitrogen oxides and carbon monoxide. Now, if we look at different pollutants, so if we look at, say, ammonia, so ammonia shows an increasing trend. Now, if we look at the sources of ammonia, we find that the largest source is animal manure. But then animals do not increase or decrease the manure production. So, this is something that remains constant every month. The second is mineral fertilizer, that also roughly remains the same. Then we have crops and their decomposition, human waste, soils under natural vegetation, and biomass burning. Biomass burning is 13% of ammonia. Now, is there any area where we are seeing biomass burning? So, if we look at the satellite images, and here we have the heat signatures. So, these are the fire signatures that satellites are seeing, and here we can observe that in Punjab and Haryana and certain portions in UP and also certain other sporadic locations in India, we are observing fires. Now, these fires are happening because the farmers are clearing their fields of the previous cultivation and preparing the fields for the next cultivation. So, this is an easy way out. You burn the whole of the cropland because you have already taken the grains out, and the stubbles that remain, if they are burnt, then the whole area will be cleared in no time. And so, we are observing the heat signatures, fire signatures. So, this is the fire signature on 15th of October. This is the fire signature on 25th of October. See that still there is a large amount of stubble burning that is happening. This is the fire signature on 4th of November. Still you have a large amount of stubble burning in these areas. This is from 10th of November. Again, Punjab and Haryana, you find a large amount of cropland burning. And if we look at the wind directions, the majority of the winds in Delhi are coming from the northwestern direction. So they are bringing these pollutants. Now remember that the wind speeds are very slow, and so the wind will slowly bring in these pollutants, but it is not fast enough to take them away. So it is slowly bringing these pollutants into Delhi and into other surrounding areas. If it were fast enough, then the pollutants would have dispersed in no time. If you look at nitrogen dioxide concentrations, they show an increasing trend. Now, what are the sources of nitrogen dioxide? The major source is automobiles. So, as much as 58% of nitrogen dioxide in the atmosphere is coming from the mobile sources, especially automobiles. Now, Delhi has a very high car concentration, and so it is inevitable that the nitrogen dioxide concentrations would increase when you have a situation of temperature inversion, because any nitrogen dioxide that is released into the air, it is stay put, it does not move away. So over time the nitrogen dioxide concentrations would increase. If you look at sulfur dioxide concentration, it shows an increasing trend, but there is also a sharp peak here. Now, what are the sources of sulfur dioxide? The largest source is electricity generation. So sulfur in the coals, when it is burnt, it produces sulfur dioxide. And Delhi also has thermal power stations which are producing this sulfur dioxide, which is being released into the atmosphere. But we also have the festival of Diwali, and when people burn crackers, they also release a large amount of sulfur dioxide. So this peak, this hump, is because of the crackers, or mostly because of the crackers that are being burnt during the Diwali festival. If you look at carbon monoxide concentrations, they again show an increasing trend, which is expected in the temperature inversion period, and all of these combined are leading to an increase in PM10 and PM2.5 concentrations. So basically, if we look at a situation like Delhi smog, we cannot just pinpoint a single source, because all of these sources are contributing. Once you have a situation where there is temperature inversion, the air is not going anywhere. So if anybody is releasing pollutants into this air, the pollutant concentration would go up. But what is important to note here is that the agriculture sector is also contributing, and in a major way, because of the stubble burning that is happening in these times. So when we talk about land as a resource, we find that a major chunk of land is being used for agriculture, and this is also having a large number of negative impacts on the environment, which has very important ramifications for conservation. So that's all for today. Thank you for your attention. Jai Hind.